You're part of a university admissions office and need to keep track of the kth highest test scores from applicants in real time. This helps to determine cutoff marks for interviews and admissions dynamically as new applicants submit their scores. So you are tasked to implement a class, which for a given integer k maintains a stream of test scores and continuously returns the kth highest test score after a new score has been submitted. More specifically, we're looking for the kth highest score in the sorted list of all scores. So sorted list of all scores. Interesting. Okay, so they want us to implement the kth largest class. We can see that here. There's a constructor that they want us to implement where we initialize the object with the integer k and a stream of test scores nums. They also want us to add a new test score val with this add method to the stream and then return the kth largest element from the pool of test scores so far. So whenever we are looking for the kth largest or the kth smallest of something, we might want to look into a heap solution. So that's what we're going to be doing. So a couple of things about a min heap. We can access the smallest element from a min heap in constant time. That's like the benefit of a heap. So O of 1 access on the smallest element. We also get O of log k time complexity to insert and remove elements from a heap or to push and pop elements from a heap. So that's because the heap is going to be semi-sorted. So that's why there's some time complexity pushing and popping, but we always, we get the guarantee that we get the smallest element there in constant time. So that's going to help us solve this problem because say we want the fifth highest test score, say k equals 5 from a pool of test scores or that are coming in as a stream. And we want to be able to get the kth highest test score and, very quickly each time we insert something. So a heap is going to be perfect here. And let's do a heap as an example. So say we have some scores in here. Okay, we're just adding scores from a stream. Okay, now we get a sixth score comes into the stream and we have, let's say it's just a 104. So basically what's going to happen for our heap is we're not going to let it grow bigger than size k. We're not going to let it get bigger than 5 elements. So we're going to check, okay, is it bigger than 5 elements? What the heap is going to do if it is it's literally just going to reject it's going to get rid of the smallest element. So this 66 is going to go bye-bye. And now our heap is still going to be, the right size. It's going to be size 5. And we're going to have constant access still to this smallest element, which is the 77. Okay, so another element could come in. What if a 50 comes in? Okay, well, we're going to check, is our heap bigger than 5? It is now. Reject the smallest element. So the 50 just literally gets rejected immediately, doesn't ever go into the heap. Okay, let's do a score in the middle. So if we add a 90 to our heap, that's now greater than size 5. We do that check ourselves, right? The heap doesn't do that for us. That's part of our solution. We'll check, is it greater than 5? It is. Okay, we'll reject the smallest number. So we get rid of this one. That's pretty much the problem in a nutshell. And that's also what a heap is. And if we limit the size of the heap, we can use it pretty cleverly to solve problems with pretty clean code and pretty quickly with time and space complexity. And I'll talk about the time, the space complexity of this class and then the time complexity of this method after coding the solution. But for the solution, let's have some private data members. So we want to weigh to keep track of the whatever k is. So like this add method needs to return the kth largest score every time. And yeah, we just need a way to keep track of that. We also get k here in the constructor. So let's just make an integer k. And then we also need, well, let's just set that in the constructor. So we'll say this k from this class is going to be equal to this k, the k that is the parameter of the constructor. So the next thing we want to do is have a min heap. So in C++, heaps are called priority queues. And we're going to have a min heap of integers. That's going to be the type. And then the next thing is the structure it's implemented as under the hood. A vector of integers works fine. Since it's a min heap and not a max heap, you do get a max heap by default in C++. So to make it a min heap, you just use this comparator as a third type. So greater comparator. And then min heap is what we'll call it. So for the constructor, we literally just want to iterate through all of our numbers, all of our num in nums, each num in nums. And then we're going to say const int, const by reference, because if you don't say by reference, it's going to make a copy. We don't need to make a copy, but we also don't want to modify what's in place. So we're saying const reference saves memory, and then it keeps the safety. We're going to use this add function to populate the min heap. So let's say min heap or this add, and then we're going to just pass in that num. Okay, so let's implement this add function. We're going to ensure that the heap stays, has no more than k elements. That way we always get that smallest element. And it's, well, we're always going to get the smallest element from a heap. But if we don't allow it to grow greater than k elements, then we will ensure that the smallest element is always going to be the kth largest in all of the incoming elements we've seen, right? So first thing, we can just do min heap dot push val. Okay, then let's check. Okay, like is the heap, so if min heap dot size, if that grows larger than k, if that has grown larger than k, since we just added a value, we're going to pop from the heap. Okay, and that push is logarithmic. This pop is logarithmic log k, right? K is the size of the heap, because that's the number of elements in there. That's the size of that search space. So min heap dot pop. And then at the very end of this, we can just return min heap dot top. That's going to be constant. So overall, this method is going to have big O of log k time, right? Because we have logarithmic time for pushing a value, a log k time for popping a value, and then constant time for getting that top value. And then this constructor is going to be the time complexity is actually going to be different. I mean, it would be log n time, right? Because you have to, or not just log n, right? Because the add isn't constant, right? The add is log k. So it's going to be log n, let's see, or not log n. It's not even log n. Okay, that was confusing me. That didn't seem right. Okay, so it's big O of n and big O of n log k. So like in times, we're going to be doing this log k operation. So big O of in log k time for the constructor. And then we just need this space complexity. So the space complexity is going to come from the state, and it's going to be big O of of k space, right? Because it's never going to get bigger than k as long as we're, respecting the use of this setter here. Yeah. So that's pretty much it for the problem. Hopefully I didn't make any bugs here. Cool. Okay. Yeah. So hopefully this helped, and I'll see you guys in the next piece.